My name is Mauricio Salatino. I am working for a company called Diagrid, who is running this stream, but I also wrote this book titled Platform Engineering on Kubernetes. I consider myself still like a developer, a software engineer, and I'm also a CNCF ambassador. So I've been working with CNCF project for some time now, and currently I'm focusing mostly on Dapr, on Knative, and some other projects like Crossplane and Captain, because I love these projects, but also I love the idea of combining projects together to actually build platforms that can be used. In the Spring Boot side, when we talk about developers, usually we build platforms for developers to be more efficient when they do their job. So they don't need to learn all these projects and all these tools. They just focused on building applications. The book comes with a repository full of tutorials, and I'm super happy today because a Japanese community member wrote me to translate these tutorials to Japanese as well. So if you're a Japanese speaker, you can help me out with that. Or if you are like a native speaker of any other language, please join me into translating this into multiple languages so more people can go through these tutorials. There is a tutorial on Dapr there as well. It's not using Java in that case, but I'm pretty sure that if you get interested in Dapr enough in this presentation, you can follow up with that tutorial. The book comes also with a discount. So I need to thank Manning for providing a discount for this session. So if you use that code or scan this QR code, you can get 45% discount on the books. But also I will be raffling a couple of books at the end of the presentation if you stay until the end. And if you play with me with some games that we're going to be playing, you can get a couple of free ebooks just for you to read without having the printed version. So let's get started. We all know, building distributed building distributed systems is a complex task, right? Like because distributed systems are complex, you will need to kind of like understand how they work, understand the challenges that you will face when you're going through that process, and then you need to train teams in order to get all that expertise and be proficient in the way that they design and the way that they code these distributed systems. There are a bunch of very common challenges that you will face, and we will be talking about some of them during this presentation. And then if you go into the other side of things, if you start trying to run your applications on top of something like Kubernetes, then if you put developers to learn all that technology stack, developer productivity will suffer because they will end up learning about a bunch of new tools, but also writing a lot of YAML and stuff like that. That it's pretty much not the part of their job. So if you are interested in these topics, I wrote a very, very long blog post about Dapr and Spring Boot in the Diagrid blog, so please check it out. It's pretty much covering the topic of this presentation, but going into way much more detail than the one that I can just do here in just 1 hour. So let's start this presentation by just like working with an application, right? I created this application based on a very popular Docker example that you can find in that repository, and we extended it to basically being built with Spring Boot, like all the services. In the Docker example, you will find examples in .NET, in Node, and Python, I think. Here, we just created a bunch of other services, and we wrote them all using Spring Boot. So if you're a Spring Boot person, you should be able to go into the source code and look into the projects and see what these projects are doing. But the application is pretty simple. The idea is that I will be sharing a QR code where you can just join and perform some votes between two very simple options. And the votes will be stored, in this case, into a Redis instance that is running in a remote in the cloud provider. Every time that you vote, we will be also placing a message into a RabbitMQ queue, and those messages are going to be picked up by the dashboard that is down there, that is in charge of showing votes live as they happen. On the middle here, you can see the worker that is basically picking up votes from the Redis instance and transforming those data structures into something that can be presented for the results service to pick up and quickly show the results live as well. So again, the application is pretty simple, but I think that this is a very good example of the kind of things that we want to do when we are building distributed applications. We will have different services. They all communicate between each other using different mechanisms. It can be messaging, it can be service-to-service invocation, or it can be through a data store that is storing information and allowing two services to do different things with that kind of information. So let's try to use the application. And this is where things can go wrong because it's a live demo, of course. And also, I need you to interact with the application that is running. So if you can scan this QR code or just go to that link, you should be able to see the application. Let's see if that works out. Let me see if I can go out of my application here. And then let's see if I refresh here the screen. and see if we can get some interactions from the audience. Okay, so I can see some votes coming in. You can see here that I have the results UI, which is basically showing the data that it's being collected from, in this case, PostgreSQL, where the data is being stored for showing this. In this side of the screen, every time that somebody press the button, you will see some emojis floating around. That's pretty much the result of sending a message via RabbitMQ and somebody subscribing, in this case, this application subscribing to those messages. So you can see that that will be changing and that the data will keep changing. And when you vote here in the application, you will get like a user ID here. At the end of the presentation, we will use that to do some raffling. So you can keep voting during the presentation. The idea here is that when I run this demo with the live audience, like in an in-person event, you get like 100 something votes of people voting at the same time. So it gets really, like the application start getting some demand, and we can make that application scale as well. This application, of course, is running on a cloud provider, and I wanted to talk about that a little bit, like about how do you run this into an application runtime that can be on an on-prem setup, or it can be something that runs in a cloud provider like Amazon, like AWS, or Microsoft Azure, or Google Cloud Platform too. So let's talk a little bit about that. One of the things that I see more and more and more that people run these kind of applications in different cloud providers or cloud native runtimes. And a cloud native runtime can be Kubernetes on its own, right? Like if you are working in the cloud native space, you might have heard about Kubernetes. This is a container runtime, like it's a container orchestrator, but that's where you're going to run your applications. Or it can be a cloud provider like the ones that I mentioned before, or other cloud providers too, that will basically allow you to run applications. They will give you VMs or runtimes where you can just run these things. Containers are becoming the default option for most companies trying to move to containers just to run their applications. And it's pretty good because the Spring community has sorted out how to create containers from Spring Boot applications pretty easily. So if you're coming from Spring, you know that now you have a Maven plugin for Spring Boot by default that allows you to build an image using a project that it's called Buildpacks, coming from the cloud native community. At the end of the day, what you want to do is you want to get a container image that you can distribute, and then you can just run into these different cloud native runtimes. It can be Kubernetes running on-prem, or it can be a Kubernetes instance running on Google Cloud, or it can be a container service like App Runner or something that a cloud provider gives you, where you can just send a Docker container and they will just run it for you. And we all know, like with containers, we can save time, right? Like if you are coming again from the Java community, you know that instead of installing a Redis instance in your local machine and installing RabbitMQ manually into your machine, you can just actually run these instances as containers. And because you can run also your boat service, in this case, as a container, you can distribute it so other teams that don't have the entire development set up for the boat service can run the boat service if they want to run integration tests or some other tests where they are building features from other service, but they need to have this running as well. In the Java community and in the Spring Boot community, we need to give a shout out to test containers because they actually simplify the whole process of starting and stopping containers for testing purposes. So if you are writing a Spring Boot application and you need to start containers in a programmatic way, just using the JUnit libraries for creating tests and automating when these containers start and when these containers stop, how to load data into these containers and all these things, test containers library is one thing that has helped us a lot to go faster and just to create these reproducible environments by relying on containers, but managing the life cycle of these containers for us, which is something very painful to do if you want to do it manually, or writing Docker compose files and then scripts to define when to start and stop these different Docker compose files for different scenarios. If you look deeper into these kind of applications, and I'm using the vote example, the vote service example, mostly because it actually do two things. One is store votes on the Redis instance, and then it publish a message into a RabbitMQ queue. So what you will do as a Spring developer, this is pretty much what I've been doing for the last, maybe 8 years, is like look into the Spring framework abstractions like Spring Data. And in this case, I'm using RabbitMQ, so there is a Spring AMQP integration that allows you to connect to things like RabbitMQ that follows the AMQP protocol. So in this case, we have Spring Boot as the framework, plus something like Spring Data and Spring RabbitMQ and then the Redis client and the RabbitMQ client to actually connect to the instances of these containers that are running, in this case for local development, but in production, they will connect to the real instances that are running these services, right? Important thing to mention here, and that's why they are like reddish, is that you need to have the right client for the version of the infrastructure, in this case Redis or RabbitMQ, that you are running, right? So if you're running, Redis 7 or Redis 5, you need to make sure that your client matches with that version. If they don't match, you will have troubles, right? Because maybe they match for the local unit testing that you're doing, like the integration testing that you're doing with test containers, but when you run this in production, then you will need to have a different client in the class path. And that creates some problems there, because now the application code and the dependencies of the of the application that are bundled all together inside a container are depending on a very specific version of Redis to be running in that space. Teams have been doing this for a while. It's a complicated thing to break, just to break this dependency, but we will be looking into how Dapr can help with this. It's kind of interesting if you're running inside Kubernetes, you don't even know where these things are running. They can be running inside your Kubernetes cluster, Redis and RabbitMQ, or they can be running, outside. It can be a managed service even for Redis or RabbitMQ that it's not even running close to the cluster. So as a developer, you need to know where they are and how to configure, how to create the connections to this infrastructure. The problem with that approach, right, like of just including clients and including specific abstractions that are being built for specific technologies, is that if you want to move to run your application in Google Cloud, for example, or in AWS, then you will need to change once again the dependencies, and in this case, maybe the code that is created to interact with these very specific providers. In this case, you will use something like Spring Cloud GCP just to use Spring Data and Spring Messaging without knowing that you're interacting with Google Cloud. But if you created already a container with the Redis client and the RabbitMQ client, well, now you need to create another container to run in Google Cloud with completely set of dependencies that will push you to just rebuild the container and retest everything. The same thing for this one, right? Like if you're running against Spring Cloud GCP, how do you test that locally? Unfortunately, I'm not aware of any container or any solution that allows you to test, GCP services locally. I know that for AWS you have local stack, but for GCP I'm not entirely sure. When you go into Kubernetes and when you start building more larger and more complicated distributed applications, things can become a little bit more complicated because you need to start dealing with other concerns inside your applications, like resiliency, for example, or accessing secrets or accessing configuration from configuration stores, right? In Spring Boot and the Spring Cloud community has been building all these abstractions too, like all these interfaces to abstract away different providers for configuration stores, or these mechanisms for example, implementing circuit breakers or retry mechanisms, right? So you will be adding more, dependencies to your application to do those things. And that's all good. And some people have been doing this for a long time too. But again, you keep adding stuff into your applications, making your applications larger, pushing your developers to learn about all these concerns that maybe we can just delegate into a separate layer, mostly if you are running in Kubernetes. So Dapr tries to answer that question. Can we delegate some of these responsibilities that the application is taking while connecting to infrastructure, while implementing all these secret breaker mechanisms or service discovery mechanism into the application runtime, in this case Kubernetes? And that's why the Dapr project was created, right? Dapr stands for Distributed Application Runtime, and it's like a Kubernetes extension. So it's something that you install inside your Kubernetes clusters. And it basically provides a set of building blocks, a set of APIs that allows you to perform some of these things that you will be doing when you're implementing distributed applications. We talked before about like connecting to Redis, to RabbitMQ, and that can be summarized as state management. You want to store some data for your applications to use, right? You want to publish and subscribe to messages that can be sent via message brokers. Actually, from an application perspective, it doesn't matter which mechanism are you using, right? Like you can be using Kafka, you can be using RabbitMQ, you can be using a managed service in a cloud provider, but the functionality still is the same. What the developer wants to do is want to submit a message or publish a message and then subscribe to those messages from a different service or a different application. The same with storing state, right? We have then service-to-service invocation, just discovery, which services are available, how do I connect to them, are those connections load balanced, and all these things. And then you have other things that build on top of these things, like distributed logs or workflows, or accessing to secrets and configurations. These are things, again, that most applications will need, and Dapr focuses on providing APIs for these applications to do these things instead of adding libraries by just calling APIs. So if you are more like a developer, I will try to explain how does this work from a runtime perspective, because I think that for people coming from the Kubernetes space, they need to understand what it means for us to install Dapr into a cluster and how it will work with the applications that they already have. So how does it work, right? Like imagine that we have this Spring Boot application that it's the boot service of the application that we were using before. We install Dapr into the cluster. That's the first thing that we do. And then we want to deploy our boot application into our cluster. We can have RabbitMQ or Redis running inside the cluster or outside the cluster, or again, it could be a managed service. How does it work? The first thing that you do, like the first different thing that you do with your application, is you annotate your workload with a set of Dapr annotations. So basically you are saying, my application wants to consume the Dapr building blocks, the APIs that I was describing before. The next thing that it happens is that the Dapr components that are installed in the cluster will detect that there is a new application that wants to consume the Dapr APIs, and they will inject a sidecar. This is a container that will run very, very close to your application in the same namespace, in the same network namespace, that will allow people to basically do requests to this sidecar as if it was a local service, right? It will not go through the network. The Dapr sidecar will expose these APIs using HTTP and gRPC for the application to consume this functionality that I was mentioning before, like service-to-service invocation, circuit breaker retry mechanisms, state management, publish and subscribe of messages, and all these things. The Dapr sidecar will read some configuration that will be in the environment, and that's kind of like more like on the Kubernetes side. You can create Dapr components that basically will tell the sidecar how to connect to the available infrastructure, right? So basically, based on that, those components, those configurations, like the Dapr sidecar will connect, in this case, to RabbitMQ and to Redis, taking away from the application the responsibility to basically deal with the connection to these services and deal with the lifecycle management on how this connection needs to be managed. In this case, now the application, the only thing that it needs to do, it needs to basically call these APIs using HTTP or gRPC, and then the Dapr sidecar will be in charge of connecting with this and just performing the operations that the user wants to do. If you think about this, now we have removed the clients, the Redis client and the RabbitMQ client from the both application service class path. There are no more dependencies in there. The only thing that the application needs to do now is call the APIs. So in a way, and for this example, for storing state and publishing messages, what we are doing is we are abstracting away infrastructure and providing APIs for users to consume from their application code. You can imagine that because we are exposing HTTP and gRPC endpoints, there is no, there is no limitation on which languages to use. Like the application can be written in any language that can send HTTP request or connect via gRPC. And that brings kind of like a good advantage of saying, then if you want to replace, your Redis and RabbitMQ for some managed service provided by Google Cloud, you can do so because Dapr will allow you to connect to this new infrastructure, but it will keep exposing the same APIs to your application. If you want to do the same with the AWS, you can do so. And if you go to the Dapr website, you can see all the components, all these configurations to connect to different infrastructure that are currently supported by Dapr. But most major cloud providers are supported, and you should check out kind of like what other APIs are also supported depending on the kind of things that your applications are doing. And because we have sidecars now, which is like a common pattern into the Kubernetes space where you run this container very close to your application that can intercept or be kind of like some kind of proxy between your applications. You can start doing this more advanced stuff like what I mentioned before, like service discovery or retry mechanisms and circuit breakers, because now your application is calling an API, and behind that API, the Dapr sidecar can have all these mechanisms to deal with resiliency concerns and security as well, and tracing and logs and encryption between service calls and all that stuff. You can use all these mechanisms also to interact with external services. So if the Dapr, like if your application wants to interact with an external service, and you want to automatically have retries on those calls or logs and metrics, you will get that all out of the box by using this approach. But you might be wondering, right? Like, I'm a Spring Boot developer. In this case, you are talking about Dapr and how do you install it in Kubernetes? How does it work, right? Like, now this becomes a little bit more like an infrastructure concern, because you need to have a Kubernetes cluster, you need to install Dapr into it, then you need to learn Kubernetes, then you need to learn Dapr. As a developer, what I wanted to do is I wanted to provide a deeper integration for developers to actually be able to work on this from their local development environments, right? If I don't want to learn about Kubernetes, I should be able to use the Dapr APIs in the same way. And that's why we built, like the Dapr and test containers integration. Once again, if you are in the Spring Boot community, you know test containers. We built like a custom integration for Dapr. So now we can just actually start all the things that we need for Dapr locally when you start your Spring Boot application. And this is the more painful part of the presentation, because I will be doing some live coding to show you how to interact with the Dapr APIs, and also to show you a bit like about the life cycle of these applications and the kind of things that you can do. I've showed you already the demo before, like of this application. I will just show a simplified version of this now, so I can code it live instead of like showing all the application code and all those things. That might get more complicated. I can share the link of the application code if you're interested into that as well. So what I have here is I have VS Code. I have a simple Spring Boot application. It's using Java 17. I can use Java 21 as well, but it's basically including the basic dependencies of Starter Web. And I'm adding two things. One is the test containers dependency. This is for tests only. And then I have the integration between Dapr and Spring Boot. Besides that, there is nothing more there that the test containers dependency and then just Juniper for JUnit. Nothing else actually involved into the application. The application doesn't have much besides a REST controller, and I created a record. I like docs, so I will be just dealing with docs during this presentation. And yeah, so basically the idea here is that as a Java developer, you should be able to interact to the to the Dapr APIs that I was mentioning before using HTTP or gRPC. But for all the major languages, the Dapr project provides SDKs that you can use. So if you're using the Java SDK and the Spring Boot integration, one of the things that you can do is you can first of all create a Dapr client. The Dapr client will give you access to the Dapr APIs, and because we are in Spring Boot, you can actually do you can auto wire this client, so you don't worry about like creating these clients or managing the life cycle of that client. Spring Boot will take care of that concern for you. And for that, what I will just do is I will create Dapr client builder that will be injected here, automatically auto wire there, and then I will do Dapr client builder build, right? So without doing much, I have my my Dapr client ready to be used, right? I will import this. Sometimes VS Code doesn't import the right things, but now it seems to be working, so I'm happy that that's the case. So as I mentioned before, one of the first things that we're doing in the boat service is to store state, and let's just do that, right? Save dogs, save dog, right? We can do that. And what do we want here? We want the dog. So if I, for example, create a post endpoint here, post mapping, we can call it dogs, something like that. And basically what we want is we want to store a dog that I'm sending, via an HTTP request, in this case, to this URL. And I want to get the request body, which is basically going to be a JSON payload to basically get the dog content in this case. So let me import this. I don't want to return anything here. Basically, that's pretty much what I want to do. And how do I do it with Dapr? Now that I have the Dapr client, I can usually use the save state method in here that basically will allow me to store, in this case, the content of the dog object, in this case, into a key value store. The first thing that I need is a string that represents the key value store that I want to use. And this is the thing that a cluster administrator in Kubernetes will configure. In this case, I will use this one, key value store, right? And then what I need to provide is the key for the object, right? Like remember that in a key value store, we store keys with values, key value pairs. So we need, first of all, the key. And because I'm brave, I will be using the emoji for ASCII. And then the only thing that I need to provide is the object. But because this is a reactive implementation, we need to block here just to make sure that this gets executed before the request goes out. So only with this line, we are just storing our doc content that we will be sending via HTTP request into a persistent store, in this case, a key value store. That can be Redis in the case of our bot service application is Redis, right? Now, the next thing that we want to do is we want to get this doc out, right? Like we want to store it, but we also want to get it out. So we will just create a get mapping docs, same, but it's in this case is a get request. And here what I want to get is a dog, and get dog by, it can be by ID. That's kind of like what we used to do, but in this case it's the emoji. So let's give that a try. And I will return, basically, again, I will use the Dapr client just to get state, right? And the get state here, it will have the same parameters. So the first thing is like, which state store do I want to use to retrieve that? It needs to be the same as the one that I'm storing it. The idea here is that by just using a string, I can reference to different state stores and store data in different places that are configured on the infrastructure side on the Kubernetes cluster. In this case, we're running remote locally, so we have the default configuration for that. And what is this going to ask for? This is going to ask for the key, which again, we will use the emoji as the key. So that basically means that I need something here like a request param that we will call emoji. And it will be string because emojis are strings. So that's pretty much what I need. And I need to retrieve it. Probably I need to provide also what kind of object it is. In this case, it's a dog. So that's the type. And then as I need to do again, I need to block because this is again a reactive implementation. So I need to wait for the response to come back. And then I need to do get the value, right? Just to get the value, right? Because we have a wrapper around that object with some metadata about it. I think that that's pretty much it, right? So now I have kind of like a very simple application that can store docs into a key value store by using the save state being used by the Dapr client. As I mentioned before, you can be doing this as an HTTP request. You can be sending a post request to the Dapr APIs using HTTP without using the Dapr client, in this case, the Java SDK. But the Java SDK will save you from like doing a lot of HTTP or gRPC manipulation. So you can go super fast with this. If you do this, then the next step is to try it out, right? So if I go here, if I go to my application, first of all, let me do this package. Let's see if this compiles at least. When live coding, sometimes you don't even know if this is right or not. So it seems that it's okay. So if I do something that Spring Boot developers do all the time, which is Spring Boot run, the application will start, of course. It should start. Let's see. Yeah, it started. It's running. It's on port 8080. So the first thing that I can do here is I can do HTTP this one. So basically, I want to send a post request. I'm using HTTPy, which is this command line tool that allows you to send HTTP request easier than with curl and other tools. So basically, I'm sending a post request to the /docs URL, and I'm sending the emoji of the dog as the key, and then the name, in this case, Jerry. Right, and you will see that this is failing miserably. And if I go here to the application, you can see that, okay, basically it's saying, well, you're just trying to use the Dapr APIs, but there are no Dapr APIs running here, right? And that's what I mentioned before, right? If I'm running the application in this mode, that's kind of like how I'm going to run my application in production when it's running inside a container. And for that, I need a container, and I need Kubernetes, and I need Dapr to be installed so it knows where to connect to the Dapr APIs. If we want to run the application locally, what I've done here is I've used that test containers and Dapr integration that I mentioned before to configure Dapr for like local development purposes. So what you can see here is that we have created this Dapr container that contains all the things that you need in order to start Dapr right besides your application when you're running in Spring Boot. This is a test configuration, so it will not run when you're running in production. It will only run when you're running your application locally for testing purposes or for development purposes. So you can see here, I have configured this, key value store that I mentioned before, and I'm using, an implementation that will run in memory. I did that, but actually what I'm planning to change this example with is just to basically start a Redis instance here. With test containers, you can do something like Redis container, and then you create that Redis container, and then you can just configure Dapr to connect to that Redis container. We have some tests already doing that, but I didn't include that into the example. And I will be doing kind of like the same for, let's say that I want to start like the RabbitMQ container using test containers, and then I will just bind that to use when I want to submit, publish, or subscribe to events. In this case, I'm just using the in-memory implementation of this. This makes the application and the entire thing start faster because I don't need to load more containers. But if you're building more complex applications and you need for some reason to run, Redis or RabbitMQ, you can do that and wire everything together, right? There is one more thing that I wanted to mention that I didn't mention before, is that when you work with Dapr, it's not like just calling a database to, for example, to store data. In this case, Dapr can call you back, and we will be seeing that when we talk a little bit more about messaging and sending and subscribing to messages. And for that reason, we have this line here in test containers, which basically let containers started by test containers to communicate back. Like it's a callback way for test containers, the containers, in this case, the Dapr container, to connect back to the application. So if we have like a bidirectional connection between the application and, in this case, Dapr. So in order to use this test configuration, we will be using something new in Spring Boot 3, which basically allows us to run the test context for our application. And for that, we use Spring Boot test run, right? So that's Spring Boot test run. And in this case, you will see that now the Dapr container is being started and some other Dapr containers are started, just to make sure that we have everything for Dapr to work. We haven't used any Kubernetes. We haven't started any Docker containers manually. Like we now have the Dapr APIs right besides our application running, enabling us to build applications using the Dapr APIs, but also test them and do all the things that you want to do with your applications. So if I send the same request again, now I get a 200. That basically means that the dog in this case was stored correctly. And now basically what I can do is I can call the get method. In this case, let me see if I have it here recorded somewhere there. So in this case, I'm sending a get method with the emoji for, in this case, Jerry. And I can see that the dog object was retrieved from the state store, in this case, an in-memory thing that is running behind the Dapr APIs. The beauty about this thing is that, again, if you want to run the same code against Redis, you don't need to change anything. You just need to change the Dapr configuration to connect to a Redis instance. If you want to change that for, let's say, the in-memory state store in Google, you can do the same. Just change the configuration to connect to that instance in Google Cloud. The application APIs and the code will remain the same. So let's move forward quickly to the second thing that I wanted to show, which is the PubSub side of things. That's publish and subscribe. And as you can guess, we will be doing something pretty similar. So we will be doing a post mapping here, and we will call it like dog events. And this one will be something like publish dog event. And what do we want to do? We want to basically publish as an event the payload of this request. So if we're getting a dog, we want to just publish that. How do we do that? We do Dapr client publish event, and in this case, what we need here for these APIs to work is we need two things. We need some kind of like the string, in the same way that we have the key value store in here, to identify in this case the message broker that we want to use, and that's called PubSub, as I showed in the configuration before. And then the next thing that we want to do is we want to specify a topic where to publish the event. We will call it dogs. And what do we need to do next is like just submit the dog. But super important, we need to block, so that happens. And that's pretty much how you send an event. That's how easy it is. You have access to the APIs, then you use the publish event method, specify the broker, specify the topic, and then the payload that you want to submit. Now, what happens when you want to consume these events from a different application? I'm going to do it in the same application, but you will do it in the same way if it's a separate service. that's how we are doing it in the voting application, right? Like the dashboard, separate applications subscribing to events. For that, we will use something like this. So we have a topic annotation that allows you to specify a name. In this case, it will be docs. That's the topic name that we're using here. And it has another property that it's called PubSub name, which we'll be using here, PubSub, right? That's the name of the PubSub. And we will create this one, which also will not return anything. We'll just print the events that we're getting. So subscribing to dog events, right? And what are we going to get here? We are not getting a dog. So what we're getting here is a cloud event, type dog, right? Event. So cloud events is a specification also coming from the cloud native space, which basically allows us to standardize like events metadata. So we're going to get an event, but Dapr will automatically wrap our dog object into a cloud event that contains some metadata about the payload and about the type of event that has been created, who created it, when and where, and all that stuff. So we get that event, and what I can do here is I can just print it, ln, and event. So I can do that, event, get data, right? I don't want to print the cloud event, I just want to print, in this case, the dog that it's inside the event. The only thing that it's missing here is one thing that we need for Dapr to work is just to make sure that we expose this as a REST endpoint, so Dapr knows where to call the application back every time that there is a message into the message broker. We call this subscribe. Dapr will automatically scan these annotations and say, okay, you have a topic subscribing to something, and we will read if there is any other annotation to say to understand where to send that message to, and it will route the event to this method that will be printed. So if I stop the application for a bit, because I changed it, I need to run it again. And now basically I will just submit an event to the application. Again, I'm not storing data now, I'm just publishing an event and subscribing to that event. And I can do that with this thing. So I'm sending a post request to /dog events. And again, I'm sending a dog payload as a JSON payload as the request padding. So you can see here that the message was accepted. And if I go to the application, we can see here that the event is null. And this always happens to me because it's a very common mistake that I make, that I do not specify where is this coming from, right? Request body. The good thing is that now I know what it is because I make the same mistake every time. So if I run this application again, now I can submit, again, I can publish an event, and now I know what I'm printing because I'm printing the body of the cloud event that's coming when I'm subscribed. You can see here that I get, the event, and this is the subscription that basically shows me that the same payload arrived. Again, you can copy this code, put it in a separate application to be able to consume these messages, and it should work. So I can see that I'm running out of time, and I haven't showed the thing that I want to show yet. So let's do something. So the main thing here is that I wanted to show is that when I show this example to Java developers, they get the idea behind these APIs and the idea of creating the Dapr client and all that stuff. But actually, this doesn't feel like Spring Boot. So can we make it more beautiful, right? Like, can we make it look more like Spring Boot? And the answer is yes, of course. And how can we make that happen is by looking at some other like Spring interfaces that they already exposed, like for example, Spring Data Key Value. They already created these interfaces to interacting with key value stores. So we maybe can implement some of these interfaces just to make it feel more natural and more like Spring Boot. So I don't need to care about the reactive, side of things, or auto wiring, or dealing with the Dapr client at all, right? I just want to store my key values, my key value pairs in the key value store, and that's it. You can see here, like Spring Data Key Value has this interface called Key Value Operations that allows us to insert stuff more object-oriented, right? Like now we're talking about the objects, and then the implementation details behind the covers will identify what's the key for that object and all that stuff. You can find by ID all the objects. You can find all, or put some queries behind that. As a user, you just create an object, call insert, and forget about it, right? And then everything is typed, right? Like I can say, okay, I want to find by ID employees, and what I will get back is an optional of employee. Or if I'm sending a query, I can just get back, for example, the list of persons or whatever kind of object I'm using to store keys into a key value store. If you look into the messaging side, like just going back to the publish and subscribe, Spring doesn't have a unified interface for doing messaging, but you will find a bunch of different implementations that they all look the same. Like for example, the Kafka template, you can see that the Kafka template will allow you to auto-wire a Kafka client behind the covers and manage the client lifecycle, and then allows us to send messages in an asynchronous way, right? Like you can do something like Kafka template send. You can see that you are specifying a topic there and then sending a message. On the other side, when you want to listen to events, you can use the Kafka listener annotation just to subscribe to topics in this case. And every time that a message gets placed into that topic, your application will get notified. If you take a look into Pulsar, which is pretty similar to Kafka, you have a Pulsar template following the same semantics. Spring template send, you will send a message, and then Pulsar listener just to subscribe to messages on a specific topic. Pretty similar behavior, right? And this makes a lot of sense because the problem that Kafka Pulsar are trying to solve are all pretty much the same. The same with RabbitMQ, AMQP in this case. Spring AMQP provides that connection to RabbitMQ that implements the AMQP protocol, and it has the same semantic. You can send messages with that strange convert and send semantic in this case, but also you have the Rabbit listener that will allow you to consume messages as subscriptions. So, we pretty much follow the same approach just to create, a better integration with Spring Boot and Dapr. And I wanted to show you that as fast as I can because I know that we are running out of time. So let's do this. So instead of having the Dapr client, we will just remove this. And what I will do is I will now use two different things, private Dapr key value template. So I have a key value template. Yep. And I have a messaging template. Right? So it doesn't want to autocomplete that, but that's fine. Perfect. So we have that. So we have these two things. Again, we are in Spring Boot, so we want to auto-wire these two things. So I don't even care how to instantiate this. I just want Spring to basically find how to configure these two things for me based on what we have in our project. So I will just create a constructor. So it gets auto-wired when this object gets constructed. And then I will just send this key value template. That's the standard things for auto-wiring. In this case, these two things that are the key value template and the messaging template. Messaging template. Okay. Oh, no. That's why. Messaging template. There you go. Perfect. Okay, so we have these two templates, and now we want to use them, right? So as I was mentioning before, like the semantics are different, and it basically will take care of most of the things for us. So if you compare these two things, now I am actually saying what I want to do from a high-level point of view. I'm dealing with objects. I'm not dealing with keys and values anymore, and I'm not dealing with a reactive stack anymore, and I'm not dealing with the lifecycle of the Dapr client. So that's been taken care of by the key value template. If I want to get data from the value template, it's pretty much the same. I have the feeling that if you're a Spring Boot developer, you know how to do this, right? Like we just do find by ID. And in this case, we will just send the emoji. And here, the only thing that I need to say is just, this is the dog class. I need to specify the type. So the Spring Boot can actually figure it out how to retrieve this for me. Find by ID, there is something missing here. I wonder what. Yeah, so this is this returns an optional, so you need to definitely get this. You need to get the object inside the optional. Of course, you will do some checks and stuff like that. I don't have time for that now, so I will just do it in the simplest way ever. And then the messaging template, right? The messaging template will allow us to do send. We will need to specify a topic, in this case, a dog. But as you can see, and as I did here, I'm not specifying, the key value store or the key value store, and I will not specify here the broker, because again, Spring Boot, we can auto pick those things from configuration parameters. There is no need to do that here, like in code. We want to just enable developers to send things wherever they need to send things. So now the application looks a little bit more Spring Boot-like, because if you're using Redis, or if you're using Kafka or Pulsar, the semantics. We are super tempted now. This is part of the work that we are doing to rename this topic to something like Dapr listener, just to following again the same semantics. Yeah, listener, listener. Yeah. So basically, just to rename that, it will make us again follow, the semantics that other projects are following, and it will make your life easier if you want to move from the Dapr, sorry, Spring Kafka to the Dapr PubSub mechanism. And again, this is just a very simple first step on the integration. We have a lot of other things planned. I just want to run the same requests again, just to make sure that the application keeps running. And as I mentioned before, we are building this integration right now, mostly with Thomas Vitali and some community members. So if you want to help us in building this, please feel free to reach out. And finally, I just can send the same requests, right? So I can do, store, I can do get, and I'm getting Jerry from there, and then I can publish events. So for example, dog events, everything works. And now here, you can see here, we have more, debugging messages if we want to just understanding what's going on. We're using the Dapr messaging template, publishing to this, PubSub to this topic and this payload, right? So that's pretty much the integration that I wanted to show you today. But I wanted to also mention that there are more things going on with Dapr and things that we will be working on this integration to expand this further, right? When we are building these kind of applications that are storing state and also emitting messages, maybe we want to do that in a transactional way. And for this case, we are using, for example, we are using Redis and RabbitMQ. Combine those two things in a transaction to make sure that whenever we cast a vote, we publish a message. It might take some time for the developer to figure it out, and it's something that we can basically configure Dapr to do out of the box for us. And that's basically what we call the Outbox pattern that will allow us to configure, in this case, the state store to every time that it receives a new vote, to automatically send a cloud event to a message broker, right? So if you take a look at the documentation, you will see how you can configure the state store, in this case, that we were using to store votes, to send a cloud event every time that somebody performs, a save. And that might be something that you might be interested in doing to simplify the development task of people of this kind of like complicated coordination between different, maybe transactional or even non-transactional, implementations behind the covers. And another common thing that you might want to do is when you start building kind of like more complex systems, maybe you need durable executions or workflows to coordinate the interactions between different systems. And for example, you want to coordinate different calls between different services. And if something breaks, you want to make sure that you have the right recovery mechanisms to continue doing whatever you were doing. You want to make sure that you use all these things that Dapr provides, for example, custom retries, and the possibility to add your own domain-specific logic hooks to build these more complex workflows and more complex coordinations. Sometimes you want to run these, coordinations for a long period of times, like long-running and stateful interactions. For example, we will be doing a workflow, and then we need some person to accept or approve a step before moving to the next activity. And you want to make sure that that's implemented in an efficient way and it's taken care by, again, the infrastructure, and you're not keeping state inside your containers, for example. And having a flexible way to creating compensation logic to undo operations. Sometimes we're doing sensitive, activity-sensitive operations or sensitive system-to-system interactions. And if something goes wrong, sometimes we need to go back to a different system to revert something that we did before. Having the right, logic mechanisms and building blocks to do that kind of operations is crucial to enable developers to just build these more complex, operations. So with workflows, you can do all of that. And as I mentioned at the beginning, I wrote a simple workflow that basically does this with the application that I showed. We are casting all the votes in Redis, so basically we can go and get all the votes from there. Then we have an activity that will pick the winner by random, and then a couple of human operations that will require validation. And that's why you see that timer there in these two things, right? Usually when I do this with the live audience, what I do is I pick a winner, ask if the winner is in the audience or if maybe they have left the room or something like that. If they are in the audience, they will come and say, yes, we are in the audience, and they will come to the front and get the book. If any of these two things takes more than 2 minutes, well, we will just go and pick a different win, right? So you can start automating all these things and creating these time constraints for when you need to abort or do something else or move somewhere else. And then finally, we will say, well, the winner's in an external system, just to use some of these capabilities that Dapr has to connect to external services in a resilient way. So if you're still here in the webinar with me, what I wanted to do is I wanted to quickly see the application here. If it's still running, let me see. So we have a bunch of votes. So what I will do is just basically do a single raffle of the winner, right? Like in this case, we have cats as the winners, and I'm a dog person, so I'm not super happy about that result. But what I will do is I will just raffle, and let's see if the winner is in the audience or not. So some drum rolls, and let's see if we get a winner. There you go. So basically, the workflow is now on that first activity of picking a winner. So if you have that hash code in your application when you voted, just get in touch. I will send you a free code for the Platform Engineering on Kubernetes book. As I mentioned before, the second task is basically to approve if the winner is in the audience or not. I will say yes. So now the winner is in the audience, and the winner should come and say, hey, yes, I got that code. And if that happens, I will just basically validate that the winner got the book, and basically that will finish that workflow instance execution. I can do the same for dogs and just raffle another books for dogs, but I will keep it just one to the winner. That's the fair option. And if you're interested in learning more about the application or running this application on your own cluster, please reach out. I will be sharing the links also in the YouTube description. So that's what I wanted to share with you folks today. I know that we are reaching to the top of the hour, so you might need to leave to keep your day going. But before you do, I just wanted to show one more thing, which is, I've shown you how to run this Dapr application locally with test containers. What happens when you run your application into a Kubernetes cluster? Well, maybe you need some tools to manage and understand what these applications are doing. And that's what we are doing at Diagrid. So in Diagrid, we are building something that is called Conductor, that you can try it for free if you're a developer, or you can get a more like enterprise account if you have a bunch, like a team of developers working with these kind of applications. You can go to that URL if you are interested in like learning more about Conductor. But what I wanted to show you is how Conductor looks like for my Dapr application that I have running in Google Cloud. Let me see if I can find that screen here. So this is the blog post that I mentioned before. And this is how Conductor looks like for my application. So what we will get out of the box from Conductor is understanding if your Dapr components are working as expected, if they are configured correctly for a production workload, and you will get notifications. For example, in this case, I'm getting a notification that I'm using a version that it's two patch versions before, so I should upgrade to this one. But from an application point of view, you will get a lot of stuff, right? Like for all the application services that are using Dapr, you will not only get metrics, but you will also get, health issues detected or security issues detected. You will get metrics about how many, requests the application is getting, how many memory the application is using compared to Dapr, and you are also going to get which components, which kind of like infrastructure components the application is using and how often, and what's the latency between these components. You can also see the relationship between the applications. And for example, if I isolate this one, I can see which components the application is using and what's the latency between these components, right? So in this case, we analyze this. So the Vault service is interacting with RabbitMQ and with Redis and by sending messages to that. And finally, the Echo application, the dashboard that was showing, the votes in real time, is picking up messages from RabbitMQ, right? So the more complex the application becomes, the more easier that you will understand how things are connecting and sending data between the applications by just looking into the Dapr, in this case, the Dapr dashboard inside Conductor, that will let you understand how things are connecting together. You can also get some information about how and which applications are connected with different components and start limiting the visibility or the scope for these applications, right? So if only the Vault application is publishing messages, there is no need for the worker to have access to that, broker, or for example, the results that broker if they are not consuming or publishing messages. And I guess that's the most important part of Conductor, that it will give you all the advisors to basically configure your Dapr applications in a more performant way, but also in a more secure way and in a more observable way. So when things go wrong, you can quickly figure out what's going on, right? Again, my installation is not the production ready installation, so I'm getting a lot of things saying, hey, you should be able to restrict the access to these components because not every application is accessing, the key value store that it's storing data into Redis. So try to scope it down a little bit. That's what Conductor is. I strongly recommend you to check it out if you're using Dapr already. If you're not, this will give you kind of like a quick overview about what Dapr is doing for your applications, and you will gain observability out of the box, pretty much not doing anything. I haven't configured anything here in Conductor. I just connected Conductor to my cluster in Google Cloud, and I just got all these things for free. So that's what I wanted to show. Thank you very much for joining this presentation. And if you're watching this on YouTube, feel free always to contact me to Salaboy in Twitter, or just check the blog post, and I hope you enjoyed.